Yo, alrighty, in this first example, actually it's a bunch of examples together here, we're going to be relating chords, arcs, and when I say arcs, I mean they're intercepted arcs and central angles, relating the three of those together. So, question number one, how are chords related to their central angles and their intersected arcs? Well, in our notes, we talked about how if the chords are congruent, then their central angles are congruent, and so are their intercepted arcs. So in our notes, we learned that congruent chords lead to congruent central angles, which lead to congruent intercepted arcs. And then we also learned that the converse is true. So all of these statements worked backwards as well. So basically, what we're really trying to say is if one of those pieces is congruent, then all of those pieces are congruent. All right, let's while we're on this topic here, let's mosey on down right here, and let's see what's going on with Sasha. She's writing a proof to show that two chords are congruent. What is her error? Oh no. She says that APB, this angle right here, is going to be congruent to angle CPD right here. And she says that the reason is vertical angles. Well, I agree with you, Sasha. I think you're very smart. So, Sasha remembers one of the first things that she learned in geometry was those vertical angles are congruent. All right, good job, Sasha. Let's see what else you got. So next, Sasha says that arc AB and CD are congruent. And she says that her reason is that they are intercepted by congruent angles. Now, Sasha, although AB and DC, they look congruent. It looks like they're congruent. They might not be, because it takes more than just be intercepted by congruent angles. They have to be central angles. And remember, central angles have to be located on the center. Their vertex needs to be on the center. So Sasha, I'm sorry, dude. You tried. You were almost good. But that is incorrect. They need to be intercepted by congruent central angles. If you would have said that, I think you would have been correct. So, Miss Sasha, you were close. All right. Sorry, Sasha. They needed to be on the center for that to be true. Up next is a cool question that I want you guys to see. It says, explain why all diameters of a circle. So let's just real quick sketch out a diameter for this goofy looking circle. A diameter would be the segment that goes from one side to the other and passes through the center. That's a diameter. Explain why that diameter is also a chord. So we'd have to go back to our definition of chord, and our definition of chord was a line segment with two endpoints on the circle. And a diameter has, guess what? Two endpoints on the circle. So explain why all diameters are also chords, because they have two endpoints on the circle. Boo! Boo! Alrighty, so all diameters are chords. Are all chords diameters? No, I could draw many chords, that follow the definition of a chord, but they don't pass through the center, so therefore it's not a diameter. So all diameters are chords. Yes, true. But all chords don't get to be diameters. Diameters are special. All right, I got one more example. You are better than Sasha. Come on, Sasha. I expect better out of you. All right. Good luck on your assignment. Use your notes. Bye. All right, here. Oh, there's a lot of parts to it, though. So first up, let's read the question. For exercises 5 through 10, in circle P, the measure of arc AB is 43. So I'm going to go ahead and put a 43 there for arc AB. And AC is equal to DF. AC, so this chord is equal to DF. This chord, those two are congruent to each other. Find all the measures that are asked for in this problem. So I'm going to do the easy ones first. I'm not even going to look at the questions yet. And I see up here that arc AB is 43 degrees. Well, you might notice that that arc AB is just half of arc AC. So I could come over here and be like, okay, BC, you are also 43 degrees. I could do that. And you know what? While I'm doing that, I know a good relationship between congruent arcs, or sorry, congruent chords, my bad. With congruent chords, their intercepted arcs are congruent. So since AC, this chord AC, and chord DF are congruent to each other, I know that their arcs are congruent. So this will be a 43 and a 43. Cool, that's what we learned in our notes. All right, and what else do we got going on here? I see that GC has a length of 2. Well, I know that this sucker's cutting our chord in half, so that's got a length of 2 as well. And I know that this chord is congruent, so both of these have lengths of 2. All right, let's see if that answers my questions. The first question says, what is DF? Well, DF is 2 plus 2, so DF has a length of 4. Alrighty, number 6 says, what is the measure of arc AC? Arc AC is going 43 plus 43, so that's 86 degrees for arc AC. Segment FH has a length of 2. The measure of arc DE here has a measure of 43 degrees. And the length of AC up here is 2 plus 2, so 4. And the measure of arc DF, so from D to F, that arc is 43 plus 43, 86 degrees. So I just had to use those properties of arcs and chords that I learned. So, well, I hope that helps your understanding with the relationship between arcs, chords, and central angles. I hope